1. Prospects and challenges of smart factory. Smart factories, also known as Industry 4.0, are manufacturing facilities that utilize advanced technologies such as automation, robotics, Internet of Things, IoT, and data analytics to optimize production processes and supply chain management. While smart factories offer many benefits and opportunities, there are also challenges and potential downsides to consider. The prospects of smart factories are as follows. 1. Improve efficiency and productivity through automation and real-time data analysis. 2. Increased flexibility and customization through advanced manufacturing technologies such as 3D printing. 3. Reduce downtime and maintenance costs through predictive maintenance and real-time monitoring. 4. Improve supply chain management and traceability using IoT and other technologies. The challenges of smart factories include 1. High initial investment and implementation costs. 2. The complexity and difficulty of integrating advanced technologies and data systems. 3. Possibility of job loss due to automation and labor cost reduction. 4. Cybersecurity risks due to increased connectivity and reliance on digital systems. 5. Lack of standardization and interoperability of Industry 4.0 technologies. 6. Challenges in finding and training employees with the skills needed to work in a smart factory environment. Overall, smart factories offer many benefits and opportunities, but it is important for manufacturers to carefully consider potential challenges and address them through proper planning, investment, and training to reap the benefits of smart factories. 2. Value and role of PLM for smart factory. The value of product lifecycle management, PLM, for the smart factory is important as it helps optimize production and supply chain management by providing the necessary data and information to support the advanced technologies and processes used in the factory. PLM plays an important role in smart factories by 1. Provides a central repository for product-related data such as design files, engineering specifications, and BOMs. This data can be used to drive automation and robotics and support advanced analytics and decision-making. 2. Facilitates rapid development and launch of new products by enabling real-time collaboration and communication between various teams and departments, such as engineering, manufacturing, and supply chain. 3. Provides the necessary data to support advanced simulation and modeling, which can be used to optimize production processes, reduce downtime and improve overall performance. 4. Provides the data needed to support advanced analytics and reporting that can be used to spot trends, improve decision-making and optimize production performance. 5. Improves the overall performance of the plant by improving the traceability and visibility of products through the entire production process. 6. It can improve the overall performance of your plant by enabling you to better manage the entire product life cycle from design to end of life. 7. Manage and track the entire supply chain from supplier to end user to help make faster decisions and reduce operating costs. In summary, PLM is a key technology for smart factories because it provides the necessary data and information to support the advanced technologies and processes used in the factory, ultimately helping to optimize production and supply chain management and improve the overall performance of the factory. 3. Business checklist for smart factory introduction/advancement. Introducing or evolving a smart factory can be a complex process involving many different elements. Here's a business checklist to help guide you through the process. 1. Define goals and objectives. Clearly define the goals you want to achieve by introducing or upgrading your smart factory. This may include improving efficiency, reducing costs, increasing flexibility, or other specific goals. 2. Identification of core technologies. Research and identify the core technologies required to implement a smart factory, such as automation, robotics, IoT, and data analysis. 3. Assess current infrastructure. Evaluate your current infrastructure and determine what changes are needed to support new technologies and processes. 4. Create a plan. Create a detailed plan outlining the steps required to implement a smart factory, including schedule, budget, and resource requirements. 5. Assemble a team. Assemble a team of experts with the skills and experience needed to implement and manage new technologies and processes. 6. Develop a cybersecurity strategy. Develop a comprehensive cybersecurity strategy to protect your plant from cyber attacks. 7. Implementation and testing. Implementing and testing new technologies and processes in a controlled environment and making necessary adjustments. 8. Employee training. Provide employee training to equip them with the necessary skills and knowledge to work in a smart factory environment. 9. Monitoring and evaluation. Continuously monitor and evaluate the performance of the smart factory, identify areas for improvement and make necessary adjustments. 10. Continuous improvement. Continual improvement of the plant by implementing new technologies and processes and continuously monitoring and evaluating the plant's performance. By following this checklist, you can ensure that your smart factory implementation or evolution is well planned, managed and executed and will achieve your goals and objectives.